This video is the very first step of a complete web project using Java Spring Boot, database, and security, all tied together with a modern, responsive front end. My name is Matheus Besson, and I'm a computer science student currently focused on Java development. I'll leave all my social links down in the description, like Instagram, LinkedIn, email for contact, and of course my GitHub profile. So without further ado, let's dive in. So just search for Spring Initializer in your browser, and it's important to pay attention to which website you are opening. The correct one is start.spring.io. Once you open the site, you'll see an interface for creating the project file. You need to choose the build type for your project. In this case, we are going with Maven. Then select the programming language you'll be using, as well as the version of Spring Boot. After that, we fill in our group, which is usually the domain name of the company where the project is being developed. Since this is a personal project, we can decide our own domain. Next comes the artifact, which is the name of the packaged file. The name field is usually the same as the artifact. Then we add a short description of the project, and finally we set the package name, which is based on our domain and project name. For packaging, we'll choose jar, and then select the stable version of Java that we will be using. Last but not least, the dependencies. Actually, this is one of the most important parts. Dependencies are frameworks or external libraries that will be added to your project and later managed by Maven's Spawn XML file. But don't worry, we can easily add more dependencies as the project goes on. We will add the following dependencies: Lombok, Spring Web, Postgres, which will be our database, DevTools, and Spring JPA. Once they are added, just click Generate. I just showed how to generate an initial project file, but actually I already had a very basic pre-made project. So I'll be adjusting a few things in it so we can start building our first API functions. Our goal here is to build a web e-commerce project, basically an online store. It will include product registration, inventory management, user roles, among other features. We'll also have modern, easy-to-use UIs and a well-structured business logic behind everything. So let's get started. Here, as you can see, I used a rough diagram just to help illustrate how to structure my product class. I know the attribute names aren't exactly the same, but the logic is still there. So let's not worry too much about it. We have created our product class, which is an entity. We are also using some extra Lombok annotations, so we can have our getters, setters, and constructors without writing too much code. For the attributes, we have an ID, with its value being generated automatically using the identity strategy, at least for now. We also add a few annotations so that our database can be created and updated dynamically, without us having to write any SQL code. Inside the column annotation itself, we can already configure some details of our table, like the column name and whether it can be nullable or not. So let's start with our repository. Inside the repository layer, we have the repository interface for our product entity. This interface extends the JPA repository, but what exactly is JPA repository? Well, it's an interface that comes with Spring JPA. Remember, one of those dependencies that we added when creating the project. For real, this interface gives you tons of ready-to-use methods to manage your entities in your database without having to write any SQL code yourself. Here are some of the methods that JPA repository already provides. Save, to save an entity to the database. Find by ID, find all, delete by ID, and count, that returns the total number of entities in the table. On top of that, you can create new methods in the interface, and Spring will automatically generate the query based on the method name. It's just amazing. Basically, if you have an entity with an attribute like forehead size, you can get data from the database just by creating a method called find by forehead size. And believe me, it will actually work. Alright, I think it's time to move on to the next layer, the service. The service layer is responsible for the business rules of the application, things like validation, calculations, and domain logic. In our project, we have the method called postProduct, which receives an object with data. That data is then transferred into our product object, creating a new product. Finally, we return the newly created object back to the user. However, you may notice that this class actually returns a product DTO. What is that? Well, we'll take a closer look at it in just a bit. Next, we have a method called findAll. Here we created a list of products which comes from the repository through the method repository.findAll. Then we return this list, but convert it into a product DTO object. DTOs, or data transfer objects, are used to move data between layers or systems. If you return the entity itself, like product, you could accidentally expose sensitive information, passwords, your pet's name, or internal IDs. With a DTO, you decide exactly what data to show. Keep your API stable even if the database changes, and it makes input validation easier. A request DTO receives the data coming from the front end. A response DTO returns to the client only the data that actually matters. And then we have our controller. The controller layer is in charge of handling HTTP requests and responses. Think of it as the entry point of the application, the main gateway where the client, whether it's the front end, a mobile app, or even an external API, connects to your system. We mark our class as a REST controller and use the request mapping annotation to set up the endpoint we'll be working with for now. Next, we inject our service class through Spring and implement a simple get method. This method will return all the registered products in a list. First, we create a list of DTOs. Then we use the service to call its findAll method, and finally, we return a response entity OK with the list of products, which will be converted to JSON. Our next method is post method, called postProduct. This method takes the data sent by the user from the front end and creates a new product object in our database. Here, we return only a response entity with a product DTO. We use request body to get the data from the HTTP request body. Then, we call the postProduct method from our service layer and finally return the response entity OK with the newly created object. Now, let's move on to the application.properties file. In this file, we'll set up some project configurations. Here we configure which dialect Hibernate we'll use to generate the SQL statements. This next line tells Hibernate what to do with our database tables when the application starts. That's why the first time you run the application, it's important to set it to create instead of update. After the tables are created, you can switch it to update if you want Hibernate to manage your tables automatically, which is what we will do here. However, for more complex production environments, it's better to use migrations like Flyway to handle versioning. I added the next line so that all SQL queries generated by Hibernate are shown in the console. This is optional, but it's pretty useful. And finally, we set up the connection to our database, including the database URL, username, and password. So let's run our application. If this is your first time, make sure application.properties is set to create. In my case, I've already run it before, so I'll keep it as it is. Just remember, if you leave it on create, your database will be reset every time and all data will be lost. Here we can see that our tables have already been created by Spring. So let's go ahead and test our API. First, let's make a GET request to the /products endpoint. As expected, it returns a list, but right now that list is empty. So on the same endpoint, let's make a post request sending the data in JSON format. For our example product, we are going to create an iPhone Air, add its price, the stock quantity, and the image URL. We can tell the request worked because of the status code that was returned. Now let's add another product, a Meta Ray-Ban display.
Pause WhatsApp video call.
There we go. Uh-oh. Well, let's see what happened there. That's too bad. I don't know what happened.
We'll set its price, the stock quantity, and the image URL, and then make the post request one more time. Now let's make another GET request to return the list of products. This time the list comes back with the products we just added. It's also important to notice that each product received an ID value, generated by the annotations we added to the ID field in the product class. Checking in our database, we can see that the products were successfully inserted and are now showing up in the products table, just as expected. And that's it for part 1 of our Spring e-commerce project. I'll keep building this step by step and sharing everything right here. Thanks a lot for watching, and I'll see you guys in the next one.